The map of our world is about to change. I'm talking about the continent of Africa, splitting into two. Well, scientists are predicting that a new ocean could be created as Africa gradually splits into two separate parts. In the future, researchers are warning that if a crack on the continent continues to grow large and separate, it will see countries like Zambia and Uganda have their own coastlines. Africa is undergoing a dramatic transformation, a process so extraordinary that it's reshaping the continent itself. The Earth's crust beneath East Africa is breaking apart, tearing one of the largest land masses on the planet into pieces. The Somali and Nubian tectonic plates are pulling away from each other, and a rift is expanding at an almost imperceptible rate, giving way to an ocean that would take the world with it. In this video, we're going to bring you all the information about what's going on and if there's a way we'd come out of this in one piece. The seismic activity leading up to the 2005 Dabahu eruption was nothing short of extraordinary. An entirely new ocean could emerge in the African continent. Reports said 2 sections of the continent have started to move apart. In September of that year, the Dabahu area, situated along the Afar Depression in Ethiopia, began experiencing a cascade of earthquakes. Over 130 recorded within a single week. These tremors were not minor events. They were measurable, powerful precursors to an unfolding geological phenomenon. Communities living in this remote area were both alarmed and bewildered by the intensity and frequency of the quakes, which caused the earth to rumble continuously. For residents who had no warning or context, it seemed as though the ground beneath their feet had turned volatile overnight. Each quake was a signal, a momentary burst of energy released as the Earth's crust pulled apart. Beneath the surface, tectonic plates were tearing from one another, and magma was surging upward into the fissures created by their separation. The scientific community took notice as instruments recorded this rare alignment of seismic and tectonic events. Adjacent water bodies such as the Red Sea or the Indian Ocean will begin to flow into these low-lying areas. This creates a narrow, elongated gulf similar to the Red Sea today. The influx of seawater is gradual and may occur intermittently, influenced by changes in sea level, tectonic activity, and local climate conditions. Finally, it progresses from gulf to ocean over millions of years. The rift widens further, and the gulf evolves into a fully formed ocean basin. As the Somali plate continues to drift southeast and the Nubian plate moves northwest, the newly formed ocean will expand, creating a distinct boundary between the eastern part of Africa and the main continental landmass. This ocean will connect to existing seas, establishing a new maritime corridor and altering global ocean currents and ecosystems. This multi-stage process is not only slow but also complex, with various geological, climatic, and environmental factors influencing each phase. It's a dynamic transformation that underscores the power of tectonic forces in reshaping our planet's geography over vast timescales. The creation of a new ocean in the East African Rift will have profound implications for human populations and the environment. Coastal communities will emerge where none existed before, providing opportunities for maritime trade, fishing, and tourism. However, these changes will also bring challenges, such as the displacement of populations due to rising sea levels, loss of arable land, and increased vulnerability to natural disasters like tsunamis and volcanic eruptions. Ecosystems in the region will undergo significant transformations as new marine habitats form and terrestrial environments adapt to changing conditions. Biodiversity may flourish in some areas while declining in others, depending on how species adapt to the shifting landscape. The East African Rift represents a natural laboratory for studying geological processes and their far-reaching impacts. Scientists and policymakers must work together to understand these changes and develop strategies to mitigate their effects on human populations and ecosystems. This includes investing in early warning systems for seismic and volcanic activity, supporting research into tectonic processes, and promoting sustainable development in the region. While the formation of a new ocean in the East African Rift is a gradual process, it serves as a reminder of Earth's dynamic nature and humanity's place within it. The forces shaping this region today, will eventually redefine the continent and leave a legacy that will be studied and marveled at for generations to come. Ecosystems are reshaped, and biodiversity often flourishes as land fragments. Isolated ecosystems form, allowing species to evolve independently. This isolation spurs biodiversity, with examples like Madagascar's unique flora and fauna that emerged after its separation from mainland Africa. The influx of seawater into rift zones creates unique habitats. Over time, diverse marine ecosystems emerge, ranging from shallow water coral reefs to deep-sea trenches, fostering species adapted to these environments. As rift valleys and eventual oceans form, climatic conditions shift. Coastal zones bring new weather patterns, impacting flora, fauna, and human activity in the region. The East African Rift holds similar potential to drive biodiversity as ecosystems adapt to its gradual transformation. Geological events like rifting have far-reaching impacts on climate systems. The formation of a new ocean in East Africa could mirror changes seen in previous epochs. About 2.8 million years ago, the rise of the Isthmus of Panama altered ocean currents, cutting off direct flow between the Atlantic and Pacific Oceans. This event significantly influenced global climate, creating conditions for ice ages in the Northern Hemisphere. As East Africa's new ocean develops, shifting sea and wind currents may alter the region's climate. Coastal zones will likely experience cooler, wetter climates, while inland regions could face aridification over time. These changes could reshape agricultural patterns and ecosystems. Geological history shows that processes like those underway in East Africa have reshaped the planet, driven biodiversity, and transformed climate systems. By studying events like the formation of the Red Sea and the Atlantic Ocean, we can better understand what lies ahead for this emerging ocean and the region it will forever change. That sounds really terrifying, but at the same time, we have technology right now that can help us take a closer look into this whole thing step by step. Modern technology plays a critical role in understanding and monitoring the East African Rift's progression. By combining satellite observations, seismic instruments, and advanced models, scientists can not only track current changes, but also project the rift's long-term transformation. The rift's evolution has been meticulously tracked through cutting-edge satellite images and GPS technology. These tools enable real-time monitoring of ground deformation and tectonic shifts, offering unprecedented detail into the ongoing processes beneath East Africa. As technology continues to evolve, so too will our ability to monitor and predict the East African Rift changes. The integration of these tools has not only provided detailed insights into the rift's current state, but also set the stage for anticipating its future. With these technological advances, humanity is better equipped to understand what's coming and prepare for it. What can be done? The people living in the immediate vicinity of the East African Rift, particularly in the Afar region, have developed remarkable strategies to survive and adapt in the face of ongoing geological changes. Because of the scarcity of freshwater resources, locals have cleverly utilized geothermal energy. In the Afar Depression, volcanic steam vents provide a constant source of heat. Indigenous communities have adapted by collecting the steam rising from these vents and condensing it into drinkable water. While living near active volcanoes and seismic zones presents serious risks, the rich mineral resources found in the region provide significant economic opportunities. The East African Rift is home to a wealth of resources, including geothermal energy, volcanic ash, and valuable minerals like gold, copper, and salt. As the East African Rift slowly transforms into an ocean, it is expected to dramatically reshape the environmental landscape, not only in East Africa, but also potentially influencing global ecosystems. But the Earth has done it before, and it can do it again. What do you think? Leave your thoughts in the comments below. And if you like this video, don't forget to subscribe to our channel, Digital Discoveries. See you in the next one.